In Lesson 4-3, you learn how to relate transformations and congruence. Now in Lesson 4-9, you're going to learn how to perform congruence transformations. So by the end of today's lesson, you'll be able to successfully create an image congruent to a given triangle. So if we look at the word transformation, it's an operation that moves or changes a figure to produce a new one. And an image is the new figure produced by a transformation. And a translation, again, just a quick review from the last lesson, moves every point of a figure the same distance in the same direction. And a reflection creates a mirror image of the original figure. And a rotation turns a figure around a fixed point. So we call that the center of rotation. And congruence transformation changes the position of a figure without changing its size or shape. So this is just a quick review. So let's look at example 1. Name the type of transformation demonstrated in each picture. So if an image is rotated, is transformed about a fixed point, then we call that rotation. And if an image is slided in a straight path, we call that translation. And if an image is flipped over a line, we call that reflection. So just a quick review. Okay, so the coordinate notation for translation, you can describe a translation by the notation xy to x plus a, y plus b. And with this shows that each point x, y of the unshaded figure, so we're talking about this one, is translated horizontally a units and vertically b units. So I mentioned this a little bit in 4-3, and this is just a more detailed explanation. So example 2, in figure ABCD has the vertices in 1, 2, 3, 3, 4, -1, and 1, -2. So I'm going to plot all of these points. 1, 2, and 3, 3. 3, 1, 2, 3. B, 4, -1, and 1, -2. And I'm gonna I'm going to connect my vertices here, okay? And then you need to sketch ABCD and its image after the translation of four units to the left because it's -4 here, and 2 units up because it's +2. So I'm going to first work this out for every point. So for 1 and 2, I'm gonna take 1, I'm gonna subtract 4 to get -3. And 2 plus 2, 4. And 4 minus 4 is 0. -1 plus 2 is 1. 3 minus 4 is -1. And 3 plus 2 is 5. And then we have 1 minus 4 is -3. -2 plus 2 is 0. Now we're ready to plot the image that's being translated. So we can go ahead and label these A prime, B prime, C prime, and D prime. And let's plot the points. A prime, -3, 4. B prime, -1, 5. And C prime, 0, 1. And D prime, -3, 0. And let's connect the vertices, and then we're done. And then this is the image, and this would be the pre-image. Okay, in lesson 4-3, you didn't really get any much practice for reflection. So let's focus on the coordinate notation for a reflection in the x-axis and the y-axis. So remember I said in lesson 4-3 that when a point is reflected in the x-axis, then the y-coordinate would take the opposite number. And for the y-axis, when you reflect the point, the x-coordinate would take the opposite. Now example 3, use a reflection in the x-axis to draw the other half of the figure. So I have -1, 0 here, and the opposite of 0, there's no opposite of 0, so it's still 0. And the opposite of 4 is -4. This will still be 7, 0, and 1, -1, and 3, -1. And let's plot these points. So -1, 0, 2, -4. So 1, 2, 3, 4, here, and 7, 0, same point, 1, -1, and 3, -1. And then we're ready to connect our points here. Example 4. Graph JK and LM. Tell whether LM is a rotation of JK about the origin. If so, give the angle and direction of rotation. So let's take a look at the segment KJ. And we can rotate this way. So if you think about taking this segment and rotating it to the origin, and then rotating it to point L and then to LM, you can tell that it's moving in a counter clockwise direction. So measure angle JOL here will be a 90-degree rotation. And then from KOM will be another 90-degree rotation. So think about from here to here and then to LM. Okay, you can go ahead and write 90 degrees in for measure angle KOM. And for part B, I've already plotted the points and drew the segments in. And I want to know if if JK is a rotation about the origin. And I'm looking at the angle here. Measure angle JOL is greater than measure angle KOM. So it's obviously not a rotation. Example 5. The vertices of triangle PQR are 2, 2, 3, 4, and 5, 2, in which I've already drawn in for you. The notation xy to x plus 1, y minus 6 describes the translation of triangle PQR to another triangle XYZ. Show that triangle PQR is congruent to triangle XYZ to verify that the translation is a congruent transformation. So let's take a look at the transformation first. So I'm going to do P prime, Q prime, and R primes. This would refer to X, Y, Z, the three vertices of the other triangle. So P prime here, we could take 2, and we're going to add 1. So it makes 3. And 2 minus 6, which makes negative 4. And then 3 plus 1, 4. And 4 minus 6, negative 2. And then we have 5 plus 1, 6. And 2 minus 6, negative 4. And then we're ready to plot the next one. So the translated triangle. So we have 3, negative 4. And that would be our P prime, or our X, let's use X here. And our 4, negative 2. And 6, negative 4. Go ahead and connect the points. And it's quite obvious that from point P to point R, it's 3 units. And point X to point Z is 3 units. And we can use the distance formula to check whether PQ is congruent to XY. So I am going to first calculate the distance of PQ, which is, let's see, so 2 minus 3 makes negative 1, so I'm going to do negative 1 squared. 2 minus 4, negative 2 squared, which is just square root of 5. And our xz, just going to look at these 2 points here. 3 minus 4 is negative 1, so I'm square that and add it to the difference of negative 4 and negative 2, which is negative 2 squared, which is square root of 5. So therefore, PQ is congruent to XY. And now I need to show that angle P is congruent to angle X, because I want to use SAS congruence to prove these two triangles congruent. And to do that, I need to first extend PQ and side XY to form an intersection at angle G. Okay, so now I've created 2 pairs of parallel sides. So the first pair here will tell me that angle P is congruent to angle G. I'm going to write that down. Angle P is congruent to angle G. And the other pair will be from here. GPQ is parallel to XY. And that would tell me that angle X is congruent to angle G. So I'm going to write that. Angle X is congruent to, let's see, angle G. So our reason would be the corresponding angles postulate. Ooh. And then therefore, angle X is congruent to angle P by the transitive property. Hence, by SAS congruence, these two triangles are congruent. So side PQ is congruent to side XY, angle P is congruent to angle X, and side PR is congruent to side XZ. So we have SAS.